Right, today we are going to start with we are going to learn about each of the component that is there in the CyberArk architecture. We'll start with CyberArk Vault. We'll understand the theory of CyberArk Vault, the processes, the backend processes that gets executed, the communication, all of those theory. Okay. CyberArk Vault. CyberArk Vault is basically a repository. Vault is basically a repository for all the privilege accounts, policies, configuration, logs, and session recording. Everything will be stored in the CyberArk Vault. Everything that you can store inside CyberArk architecture is going to be stored inside the CyberArk Vault. Right? Since it is a repository of all these information, there has to be a database. Right? So the Vault uses not modified, let's say customized version of MySQL database. Customized version of MySQL database because the database is specially built for CyberArk software, and you as an administrator, you do not get to interact with the database tables. It is something that is managed internally. As an administrator, you would be responsible to modify policies and do the configuration changes on the configuration file that you get on the user interface. You do not get to modify the database backend database tables directly. That is something that will be managed by the Vault software internally. You do not have a control over that process. Okay, so managed by the Vault internally. Needs to be installed on Windows Server OS, Windows Server operating system. You cannot install it in Linux or any other platforms or operating system. It has to be installed on the Windows Server operating system, right? And has to be 2012 or greater. 2012 or greater. 2012 or greater, because you cannot install the Vault in 2008 operating system that's already has gone out of support. So 2012 or greater. So has to be 2012 or greater. Access, since this contains a lot of sensitive information, this Vault access to the Vault server needs to be as limited as possible. Okay? You want to isolate this server from the rest of your network. You need to ensure that the directory or the network where all the other servers are stored, you're not keeping the Vault server at the same place, because it can be any server can be used to log in to initiate a connection to this particular Vault server, and that's not what we want. We want to keep it as limited as possible, as isolated as possible. Even the infrastructure admin should not have access to this Vault server. Only one or two administrators, CyberArk administrators that need to perform some maintenance work on this Vault server has to be allowed access to this particular server. So isolation is required. Isolation is required. This Vault server has to be kept isolated from the rest of your network zone. kept in separate network, separate firewall has to be involved. Okay. Access to the vault server needs to be limited as possible. Isolation is required, right? And since the isolation is required, the server needs to be what needs to be server is advised to be a physical server. Isolating a physical server is more isolation is more effective when you have the server physical a physical machine. You can see, just keep it in a separate physical location. So server is advised to be a physical server, but it is not a mandatory ask. You can install the vault in the virtual machine as long as you are sure that the server can be isolated. It can be installed on the virtual machine as well. Even in our case, in our lab environment, we are going to install it in the virtual machine itself. So this is just a security advisory to keep the server physical, just to have the more effective isolation. Okay. Uh, any additional software or and let's say any additional application, external application that are not required. The server has to be a plain vanilla server without any additional software or any external application, no monitoring agent, no antivirus software, just like you do with the rest of the servers. You might have noticed when they create the servers and the organizations, they push some default agents to do the monitoring to protect the server. In this case, we are going to keep the server so isolated that we wouldn't allow any external application or any external antivirus or monitoring agent to be installed on this vault server. Okay. So any external application or software needs to be removed before installing the vault. Even the network communication protocols that are not required for the vault's functionality has to be removed. Network communication protocols, as in the protocols that will allow your device to communicate with any outside resources within the network. Uh, those are called network communication protocols. On the vault server, we do not want any network communication protocols to be enabled except the protocols that are required for the vault functionality. Okay? So the vault functionality, for the vault to work, we only need Internet Protocol version 4, IPv4 or IPv6. But we'll go with IPv4, except Internet Protocol version 4, because this communication protocol will be required to communicate for the vault server to communicate to its component servers like the PVWA and the CPM and the PSM. So CyberArk component servers for password management and session management and front-end UI. The vault needs to communicate to all those components regularly, frequently. So this communication protocol will be an exception. The rest of them needs to be disabled, right? So if the vault is so isolated, so limited, how does the communication work actually? How does the PVWA and CPM, which are going to be installed in the Active Directory or organization's network, how do they communicate to this vault server? Let's understand that with some graphical demonstration. All right. Hope everyone is aware of what firewalls are. Firewalls are basically a boundary that restricts communication from outside the resources to the resources that are stored within that network zone, within that particular boundary. Okay, so let's say if this is the firewall that CyberArk has, any resources that are outside this boundary are not going to be able to communicate with the CyberArk vault because the firewall is going to restrict the communication, right? So we will use the firewall systems to isolate the vault server. Okay, the firewall that the vault uses is basically a default Windows firewall, Windows Defender firewall. The vault will be isolated from the rest of the network zone. Let's say this is your network zone. Let's call it organizations network. Organizations network. We'll have a lot of resources here. Let's say vault, PWA, CPM. All the component servers will be installed within the organization's network within the Active Directory domain. Okay. You have a lot of servers within this directory, within this Active Directory domain. Okay. Along with the servers, you have a lot of users. You have a lot of users here. Now, sorry, that's my bad. PSN, my bad. So all the CyberArk component will have to be kept inside Active Directory network. Okay, why? Because it is easier for your users to be interacting with the particular components. It is more easier and simpler for users to interact with the CyberArk components frequently. Let's say if you keep your PWA server outside the network, let's say you keep your PWA server outside the network. Every time a user tries to log into this PWA, every time a user tries to access this PWA, the user's machine, they will be created on the Active Directory's network, Active Directory domain organizations network. So when they try to access this PWA, this firewall is going to break that connection. This firewall is going to restrict. This is organization's network, and this is network firewall. This boundary we have is called network firewall. This network firewall is going to break the connection. It's not going to allow the user's machine to communicate with the PWA. So for the users to be able to communicate to the PWA, you have to create a firewall exception here. You'll have to allow the exception for the user to be able to reach log into the PWA. And there can be hundreds of users within the organization's network that needs to access the PWA. You cannot open hundreds of firewall exception. That will complicate the process. That will be a huge burden for management. So this is why it is more easier, simpler, and effective for you to keep the user interactive components within the organization's network where the rest of your user machines are going to be created, because users needs to interact with the component servers regularly. Okay. So component servers will be installed within the organization's network. However, these components still needs to retrieve the information from the vault. The PWA needs to retrieve all the information from the vault so it can populate all the information on the website. So we'll have to open a firewall exceptions. For these components to communicate with the vault server, we'll have to open firewall exceptions. These exceptions are what we call ports. And these exceptions are what we call ports. So there are standard ports for this communication. We use for the vault to be able to communicate to its component, we use port number 1858. This is a standard value. You cannot change that. Just as you have port number 389 for 3389 for RDP connections, port number 22 for Linux or SSH based connection. You have 1858 for the vault to communicate with its component systems, right? So this is how the communications are going to be allowed. From the vault, you'll have to open the ports to the respective systems. And from these respective components, you'll have to allow the communication to happen to the vault. So this has to be a binary communication. Your vault should be able to initiate communication to the PSM, and the PSM should be able to communicate to the vault, right? Same goes for the PVWA. The communication has to be a binary communication, and same goes for CPM. Sorry. On the Vault side, when you install the Vault application on the Windows server, the Vault is going to take control of the firewall systems. Let me write it down here. When you install the Vault on the Windows server, Windows operating system, the Vault takes control of the existing firewall system. Taking control here, by taking control, I mean it modifies certain rules, the existing firewall rules. Okay. It modifies existing firewall rules. This network firewall is not going to have an effect over this particular thing. Okay. Vault is going to be isolated by its own firewall. It's not going to be kept inside the organization's network. Modifies the existing firewall rules, disables all communication, allows only port number 1858 to work. Port number 1858 to work. So for the Vault to be able to communicate to its component servers, port 1858 has to be allowed. And when you install the Vault, it takes care of it itself. Basically, when you install the Vault, it takes over the existing firewall system, modifies the existing Windows Defender firewall rules, disables all communication, and allows only 1858 port to work. That means on this side, the ports will be opened automatically. Whenever you install these components on these Windows servers, you'll have to ensure that from here to this particular Vault server, the ports are open, and that has to be done manually. Because when you install the Vault here, it takes care of opening port 1858, allowing port 1858. But when you build the components, before building the components, you'll have to ensure that the connectivity is in place. From the PSM server, port 1858 has to be allowed to the Vault. From PVWA server, the port has to be allowed, and from CPM server, the port has to be allowed. And that is something the organization's network team is going to do. The network firewall will be taken into account here, and you'll have to raise a request to the respective network team in order to get these port opened from this as a source to this as a destination. Okay. Firewall ports, port number 1858 has to be allowed from each of these component servers to the Vault system. Right. Now, once the Vault is installed, modifications on the firewall rules, any further modification, any further modification on the firewall rules can also be done on the Vault configuration file. Let's say you want to integrate any system with the CyberArk Vault. let's say you want to integrate the Active Directory systems with the Vault. Okay? So you have a Active Directory here. The AD systems, Active Directory is going to communicate with a different protocol, a special protocol called LDAP, Lightweight Directory Access Protocol, which requires 389 to communicate. Just taking an example of any other system. We'll talk about AD and LDAP in coming sessions, right? So you'll require port number 389 to communicate with the Active Directory. So from the Vault server, if the integration needs to be performed from the Vault server, the Vault should be able to talk to this AD to communicate to this Active Directory in order to retrieve the user information. So you'll have to allow the firewall exceptions from the Vault server to this Active Directory. You'll have to open the port number 389 for this protocol to use to be able to communicate to Active Directory. You'll have to open port number 389, and that is the modification you can do on the Vault configuration file itself. And that is the modification you can do on the Vault configuration file itself. The file name where you do the modification is called dbpalm.ini. We'll have a discussion on this when we build the labs. We'll see what are the formats that we can use in order to provide those exceptions in order to make sure that those ports are open. But any further modification can also be done using the Vault configuration files. So this is how the communication will work in case of Vault and its component, right? Let's say we have a Vault here. And we have some accounts, some privileged accounts. Windows accounts are here. Let's say Windows account 1, Windows account 2. We have some Linux accounts. Linux account 1, Linux account 2. We have some database accounts. Some administrators are there. Call them Windows admin. Okay. This guy is Linux admin. Sorry. This is a database admin. So Windows admin in any organization, these Windows infrastructure admins will be responsible to manage the Windows servers. Manage as in perform any maintenance work. Let's say if they want to push patches, regular patches, they want to do some operations task like creating any user or pushing any policies. All those tasks this Windows admin will be responsible to do. But Windows admin would not have access mapped directly to his ID. Okay? He will have to use a powerful account in order to log into the server to be able to perform those tasks. Windows admin cannot log in directly to the servers with his identity. He'll have to use a more powerful account on the servers. He will have to use the powerful account to log into the servers and to do all those maintenance work. So let's say Windows admin is using Windows account 1 and Windows account 2 to log into the servers. And Windows account 1 and account 2 has are very powerful account on the server. Can be used to perform any task on the server. Yeah, it can be used to remove users and create users and perform any configurational changes. Similarly, for Linux admin, this Linux account 1 and Linux account 2 has all the privileges. Database admin using this account to log into the database instance and performing all the maintenance work, right? But since these accounts are very powerful accounts, there are also risks associated with these accounts. They can be used to exploit the system, right? Can be used to perform any unauthorized task as well. So when CyberArk is implemented, there will be an enforcement from compliance department that these type of accounts should be onboarded to CyberArk architecture. Okay, these type of accounts should be onboarded to CyberArk architecture. So let's say we have a responsibility to onboard Windows account and Linux account. At the same time, while we are securing these accounts, we should also maintain the availability of these accounts. These infrastructure admins should still be able to use these accounts in order to connect to the systems and perform their work. Okay, so let's say we onboarded this Windows account one here, Linux account one here, and database account one here. And we'll have to make sure that these users are able to access these accounts. So we'll have to provision their access on the vault, right? They will log in through PVW, but we'll have to give them access to these accounts, right? But if we provide the access to the CyberArk systems where we have onboarded the accounts, we'll have to make sure that access segregation is there as well. Because Windows admin can use Linux account or database account, can use any other account that it is not supposed to do, right? Linux admin can use Windows account or database account. There we can have some problems. So we do not onboard the accounts directly on the CyberArk vault. To segregate the accesses, we build containers inside the vault. We build small containers inside the vault in order to segregate the accesses. These containers are called safes. We'll build 3 separate safe in this situation. Say, let's call it Windows safe. Okay, this one will be Linux safe. And this one will be database safe. All the Windows account goes here. Right, and the access segregation will be done this way. Your Windows admin gets access to only the Windows safe. Instead of getting access to the entire vault, they get access to the Windows safe itself. Linux admin gets access to the Linux safe. Database admin gets access to the database safe. To do the access segregation, we build small units inside CyberArk Vault, containers that will be responsible to store separate accounts and define access segregation. This is what we call safe. Let me write the definition here. Safes are created using PVW. You can do both ways. You can even create safes from client installed on the Vault server. We can do that as well. But PVW, most likely PVW will be used. Basically, there will be tables. Of course, there will be tables, but I mean, it's just different different type of sections in order to define the segregations on the vault. So there will be separate tables involved. How do you segregate the information database? You create separate tables. You do not create. We do not create separate. We cannot create separate instances because it's one single database.